Hello, my name is Diana Arle de León Saucedo, and I present to you the research utilization of pre-prepared seed waste Opuntia ficus-indica indica meal as a biosorbent for various contaminants in water. In Mexico, the annual production is about 440,000 of pre-prepared, which produce seeds and additional hooks during processing. The seeds have application as an animal feed, composting, and extraction of seed oil. In addition to the current research to use this as a source of fiber, some absorbent or carbonized materials. To use this residual biomass according to the principles of the circular economy on the CDGs, avoiding that is disposing as an impact of the environment and using it to remove pollution in water, through absorption process using an anion, a cation, and an emerging pollution in solution. To determine the characteristic of the residual seeds, peer-to-peer seeds with oil from pulp extraction process and seeds with oil after oil extraction process by cold pressing and with extant solvent were used to analyze using different techniques. The three seeds were then activated with calcium chloride, sodium hydrox, and mixture of both to obtain different calcium activate materials. These materials were tested to cadmium, fluoride, and ibuprofen absorption under controlled conditions with no initial concentrations, and after 7 days, their final concentrations were analyzed by different techniques. The composition of the analysis seed residuals indicates that the primary variable is the content of the ethereal extract, as the seeds underwent the extraction process and lost oil, with the result that it is almost absent in the set with exam. The mineral content of pre-prepared sets is reported to be predominantly potassium, phosphorus, and calcium. The latter is typically present in the plant structure and is the sole variable in the composition with the remaining materials, which increase their content as the cell loses oil. The seeds are primarily composed of acidic functional groups and an acid point of zero charge, which is neutralizing as the oil is lost. As the number of acidic functional groups increases, their presence is discernible in the infrared spectrum. The results of the thermogravimetric analysis indicate that the seeds are primarily composed of cellulose. The pressed cells are exhibited the greatest loss of mass. These seeds initially have a specific area. However, the specific area increases as the oil lost and the average of pore size becomes smaller. The micrograph demonstrated that the extraction process promotes the reduction of irregularities on the texture on the surface of the material. The surface of the pre-prepared sets displays the presence of calcium crystals with varying shapes, a characteristic feature of the biomass of Opuntia. The crystals are more predominant on the surface on the set outside the oil dust area. The activated and natural materials were put in contact with different contaminants, presenting a high absorption capacity for cadmium and ibuprofen in the sets without any treatment. Mainly, the pre-prepared set with oil. In the case of fluoride, the chemical activated was found to favorable, resulting in an increased absorption capacity as the treatment was received, particularly in the pressed set. Finally, this is conclude that seed extraction process modified seeds characteristics in a different ways, both physically and in their composition and textural properties. The maximum cadmium uptake capacities were observed for seed residual from the pulping process and without any treatment with up of 18 mg per gram and up of 5 mg per gram for ibuprofen. For this part, treatment with calcium chloride and sodium hydroxide on seed residuals without oil from the pressing process was favorable for fluoride removal. The findings of the research demonstrate that the seeds can be employed as a biosorbent of the removal of a range of contaminants from water, either in their natural state or following modifications. Special thanks to all the collaboration in this research. Thank you for your attention.